Hey everyone, my name's Sujan Suryakumar and I'm a third year game programming student at Humber College in Toronto, Canada. I'm making this video to talk about my capstone project, One Hit Hero. One Hit Hero is a 2D fighting game heavily inspired from Street Fighter and Dive Kick. Unlike most fighting games that feature complicated combos and button inputs, One Hit Hero will be more simplified. Instead, the game will feature two players fighting, in which the first person to land a hit on the other will win the round. Because I'm working on this project completely alone, I wanted to keep the scope of the project pretty small. My goal throughout the semester was to program the core features of the game and essentially have a core game loop working. With this completed, I can now look forward to adding more characters, more polish, and replacing placeholder art for my next semester at Humber College. I'm just going to go through a short little demonstration of the game so far. Um, So I have this little character select screen. Like I said, all the art is placeholder art from Street Fighter, and I plan on replacing that over the next semester. So as you can see, the two characters can move forward, backwards. They can jump up, jump forwards, and jump backwards. And essentially, they have three offensive options in the game. They can jump up and do an aerial attack. They can do an uppercut, which has anti-air properties, so it's invulnerable to any moves coming from the air. And they can also shoot a projectile. So the game actually features no blocking, unlike most fighting games. So if, for instance, one player shot a projectile, the only way to get around it would be to jump over it or to fire your own projectile. So the game is very much mind game heavy. You don't want to be too aggressive getting in onto your opponent, but you also don't want to be too passive, or you might get hit by a projectile or something like that. So now we'll just walk you through a bit of the code from the game. Starting with the characters, I've the way I've programmed them I've done it in such a way that um, the um, the future characters I implement will be able to um, be easily added. They'll basically inherit from the scripts I've made already, changing one or two values, such as the angle the projectile fires at, or their walk speed, or their jump height, just things like that. For instance, as you can see in my animation script, all of the characters in the game are going to have the same um, three animations. They're going to be shooting projectiles, they're going to be doing anti-air attacks, and they're going to be doing aerial attacks. Um, and so, because of the way I've programmed it like this, it'll be incredibly easy for me to add new characters. It'll just be probably a few lines of code to add each new character, besides adding the artwork and things like that. I've also actually created my own physics component, um, my own physics plugin, sorry, using a DLL file, um, which I'll show you. Um, because the game only features linear motion, I wanted to essentially get rid of Unity's built-in rigid body component and create my own, which would hopefully help with performance issues down the line. So I have this physics plugin component that um, is basically created from this DLL file, um, which has a structure rigid body that has um, a velocity and position. And so basically, what I'm doing is um, I'm getting the position of the game object it's attached to and passing that into the pointer. And then every frame, I'm getting the velocity and adding that to the position. As you can see here, this update position function, it takes the position and adds the velocity multiplied by delta time. And that is called every frame here. And I've actually also implemented online play into One Hit Hero, which I'll demonstrate really quickly. Okay, so once I hit play online, I can choose my character, and then the client will start waiting for an opponent, and then I'll go on another client, choose a different character, and then they'll both connect. And if I move this, you can see both of the characters are in sync. I shoot a projectile, it fires on the other screen. Um, Although I have the online play working, I do feel there's still room for improvement because of the nature of fighting games. A lot of the um, data being sent, especially the frame data, needs to be very precise, and so there are certain um, in my testing, I found there's certain situations where the game will sometimes desync. So I hope to hopefully over the next semester see if I can improve upon that. The last thing I have to show today is I've also actually implemented AI into the game. Um, I just have a framework for it right now using a state machine. And so the way the state machine works is there's essentially four components that are used by the state machine. The state, the transition, the condition, and the action. Let me just demonstrate it for you really quickly. Um, so as soon as I hit play, now I'm controlling this character on the right over here. Now if you scroll down to the state machine that's attached to the black character here, you can see that the current state is the initial state. If I move forward, they go to the retreat state. If I move backwards, they go to the advanced state. And then I just have it set up so that every 15 seconds they'll shoot a projectile at me. Now the way this works is basically each state has um, right. So each state has actions and transitions associated with it. So the transitions basically say, so this is the initial state, um, and the uh, the transitions basically say the initial state can go to the advancing state, the retreating state, and the projectile state. So if I let's just say I go to the advanced state or the advanced transition, each transition has a condition, and so each frame of the game, the state machine will check if the condition is returned true. So for um, this, the condition for the advanced transition is the advanced condition, and so the advanced condition, all it does is it checks to to see if the player is moving forwards or moving backwards. If they're moving backwards, the AI character will begin to move towards the player. Now, this is a very straightforward implementation, um, but I just wanted to get the framework done for this semester, and so it's pretty easy for me to add um, different states and different actions that those states take. I just have to pretty much alter the conditions and alter the actions. So um, for instance, let me show you the condition in which the AI character will shoot a fireball is it essentially just waits every 15 seconds to throw a fireball. In the future, I'd like to change this so that it can perhaps keep account of um, how much time is left in the game or how aggressive the player has been and things like that. And then depending on those factors, the um, the character would shoot more or less projectiles. I would also be able to do things like if the player is jumping a lot, the state machine could keep track of that. And then if um, the more they jump, the more likely the non-player character is to use anti-air moves. But yeah, that's pretty much everything I have to show to you today. I'd like to thank everyone for watching my demonstration. And if anyone has any questions, comments, or criticism, please feel free to contact me. Thank you.